All right, each of the planets in our solar system move around the sun in an elliptical orbit, where the sun is one focus of the ellipse. Mercury is 43.4 million miles from the sun at its farthest point and 28.6 million miles at its closest, as shown. The diameter of the sun is 870,000 miles. Now, that is really important because, as I said in class, this diagram was not constructed very well. The center of the sun is the focal point. So what we need is the radius. Okay, I'm going to take the diameter and divide it by 2. So we're going to get 435,000 miles, okay, for the radius. So I created a system in order to solve mine, because basically you have combinations of the distances A and C here. Now, what I did first, remember that from the center to a focal point is the distance of C. From the center to a vertex is A. So this distance right here is going to end up being A plus C. So that's going to help me create part of my first equation. Now, what I can do is take 43.4 million. I can go ahead and change that back, expand it. So that's actually 43,400,000 miles. Well, I'm going to go ahead and combine that with the 435,000 miles so that we get straight to the center of the sun. Now, if you do that, you go ahead and get 43 million. Okay, I'll just put it right here. 43,835,000 miles. Now I'm going to go ahead and put it in terms of how the problem presented those millions of miles to me. So I'm just going to say 43.835. Now, if I look at the other side, okay, this distance right here, that is actually A minus C. All right, but I'm going to do the same thing. I'm going to set A minus C equal to 29.035. Now, if you run through the math very quickly, 28.6 is 28,600,000. If I add it to the 435,000, that's where I get 29,035,000. So I just wrote it as a decimal here. Okay, well, immediately this is perfect for elimination. Okay, add them up, the C's cancel. 2A is equal to 72.87. Okay, let me go ahead and put this in the calculator. 43, so we can see this. Okay, 43.835 plus, then we have 29.035. 29.035. Okay, so 72.87. Okay. If I go ahead and divide through, we see that A is equal to 36.435. Okay, so now I can plug that back in. I can go ahead and say maybe plug it in the first equation here. So that 36.435 plus C is equal to 43.835. And if you go ahead and solve that for C, you're going to find that you get 7.4. Okay, so now using A and C, I can find B. So let me give myself a little more room here. Now, with an ellipse, A is the longest distance. So we have B squared plus C squared is equal to A squared. So if I'm trying to find B, okay, B squared would equal A squared minus C squared. All right, and of course we have to take the square root of that. So we're looking for the square root of 36.435 squared, that's A squared, minus 7.4 squared, that's C squared. And what you're going to get for B, okay, let me go ahead and plug this in real fast. So we have this radical here, 36.435 squared minus the 7.4 squared. Okay, but that is B, which is only half of the length. So what we want to go ahead and do is find the full length of the minor axis. So I'm going to double that. So I would say about 71.4 million miles. And there we go. Now find the eccentricity of the elliptical orbit. Well, the eccentricity is always found by taking the distance of C and dividing by A. Well, if I take 7.4 and divide it by the 36.435, 0.203. We want to round that to the nearest thousandth. Okay, so 0.203. And that is number 1. Number 2, the shape of a roller coaster loop in an amusement park can be modeled by this equation. What is the width of the loop along the horizontal axis? Okay, well, we want the horizontal axis, but if you take a look, the larger denominator is below y, so that tells me that this ellipse, the major axis, is going to run vertically. Okay, so here is the horizontal, and we go ahead and draw the major right here. So basically what we're asked for here is the length of the minor axis. All right, well, we know that a squared is the larger denominator, b squared is the smaller one. So if b squared equals 225, or 2025, excuse me, we take the square root. So I get that b is equal to 45, and we're talking about feet. But again, b is only half the length of the minor axis, which is our horizontal, so we're going to double that. So it should be 90 feet. Now it says determine the height of the roller coaster from the ground when it reaches the top of the loop, if the lower rail is 20 feet from the ground. So imagine this is the loop, but then we have an additional 20 feet until that hits the ground. So what we need is the length of the major axis, and then we need to go ahead and add 20 to that. So let's see here. We need to go ahead and take the square root of 3,306.25 to find A. So the square root, 3,306, it was, what again, 0.25? Okay. 57.5, so remember that's half of the major. So I'm going to go ahead and double that. So there is the full length plus the 20 feet that it's off the ground. So we're looking at 135. Okay. All right. The height of the roller coaster total is 135 feet. Find the eccentricity of the ellipse. Again, that is c divided by a. The one value we do not have yet is c, but we already have a squared and b squared. And if we rearrange the formula accordingly, c squared would equal a squared minus b squared. Of course, we would take a square root of that. So we are looking for the square root of 3306.25 squared minus 2025. Oh, what am I talking about? That was already squared. Sorry. Okay, so 3306.25 minus 2025 below a radical. So let's see here. Control radical 3306. Oop, that's not inside. Okay. 33. That's interesting why it's doing that. 06.25 minus the 2025. So this is C, and I want to go ahead and divide it by A, okay, which was the 57.5. So I'm going to go ahead, just go up here and highlight this previous one. Okay. Oh, might help if I go ahead and push divide by. Okay, let me go ahead and do this then. Let me highlight that previous one. There we go. So C divided by A. And I'm going to end up with 0.62 when we round it to the nearest hundredth. Okay. If you have any additional questions, please let me know. Thank you very much.